Hi, second grade. Happy Monday. This is Miss Sillin with you, and today is lesson 26. This is our last lesson for Module 7. Today is for Monday, May 4th, 2020. You should be starting in your new remote learning packet for week of May 4th through May 8th. If you have not picked up your new packets yet, you can still follow along in this lesson so you stay caught up, but please make sure you pick up your new remote learning packets tomorrow on Tuesday, May 5th from 10:30 until 11:30. Today we are going to be starting on page 8. Page 13 for math homework is due, so when you are done with today's math homework, make sure you text a picture of it to me or you can email it. Tomorrow, since we are ending Module 7, you are going to be taking a test online, and you can access that on Edulastic. And I have outlined all the directions to log in on page 29. If you have any issues logging in, please contact me and I will help you out. The test does not open until Tuesday morning, and you have a week to complete that assessment. For this week, you will also have another math homework assignment that is due to me. So each week, I expect you to please text a picture of at least 2 homework assignments to me. So for this week, it will be Monday's math homework and Wednesday's math homework. And again, you have that online test on Edulastic to complete. Here is information that will be on your test for tomorrow. So in your packet, if you turn to Tuesday's math page, I have outlined information for how to access your test on Edulastic. Again, the testing window does not open until Tuesday morning, and you have a whole week to complete that test. If you have any questions on how to access your test starting tomorrow, please reach out to me. Here is what we will be doing today in my video. I'm going to give some math shout-outs here soon. Next, we will be completing the sprint test in your packet, application problem. We will review Friday's homework, and I will be going over today's concept development, your problem set directions, and homework, which is due to me as soon as you are finished. Drum roll, please, for our scholars who received 45 or more minutes on iReady Math. And if you see your initials underlined, that means that you completed over 1 hour of iReady Math minutes from last week. Drum roll, please. From Miami, we have these scholars right here. Give yourself a pat on the back if you see your initials. From CSU, we have these scholars. Great job to all of our scholars that received over 1 hour of iReady Math minutes last week. Keep up the great work. Math homework shoutouts from last week. This means I received both math homework assignments from these scholars, and I got a picture of it, saw it was completed, and I received these as of Sunday by 3 o'clock. So if you turned yours in before Monday morning, but I don't have your name listed here, it's because you turned it in after my recorded lesson. So sorry if you are left out here. This is 3 o'clock on Sunday. PCH, FDM, VD, SDG, EHP, AM, PQ, and from CSU we have CW, TQ, XM, AJ, SG, JG, and KD. Bravo to those scholars. On page 8 is your core fluency sprint test. This is all addition. Please time yourself for 2 minutes, and you only need to complete as many problems as you can in 2 minutes. Do the best you can. Ready, set, go. All done with your sprint test, please have an adult check over your answers. Turn to page 9, application problem time. Listen as I read. Judy bought an MP3 player and a set of earphones. The earphones cost $9, which is $48 less than the MP3 player. That means the headphones are $48 less than the MP3 player. How much change should Judy get back if she gave the cashier a $100 bill? We need to break this down, splitting this into two problems in our drawing space because we have to solve something first before we answer the final question. Dividing your paper in half. On the first part, we don't know the cost of the MP3 player. We need to solve for how much that MP3 player is so we can find out how much did she spend in all. How much were the headphones again? Yeah, the headphones cost $9. Headphones were $9. We don't know how much that MP3 player was, but what in the story can help us solve for the cost of the MP3 player? Do you think the MP3 player is going to be more or less than the headphones? Ready, set, go. Rock, paper, scissors, show. If your thumb is pointing up, thumbs up, you are correct. The MP3 player is going to be more than the headphones because the story tells us that the headphones were $48 less than the MP3 player. So that means that MP3 player is going to be more. On the second part, how much change does Judy get back? So you need to solve for how much money she spent in all, and then you will find your answer for how much money or change she will get back. Give yourself about 3 minutes to solve this problem, and then you can check over your work with mine. You may begin. Ready, go. All set to check over your work. If you are not finished, please pause the video and complete your work first. On the first part, how much did the MP3 player cost? And how much did she spend in all? The earphones were $9 and the MP3 player was $48 more. So that means we needed to add 9 and 48 to solve for the MP3 player. When we put those together, we get 57. Next, how much did she spend in all? You could solve this by doing 9 plus 57. And I can count up on my fingers from 57, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66. In all, she spent $66. That is not our final answer yet. We need to move on to the second part. How much change does she get back? Judy should get $34 back. 100 minus 66 equals 34. Another way that you could have solved that was by doing the vertical form. Ten minus 6 equals 4. 9 minus 6 equals 3. Objective. I can create a line plot and answer questions about the data. What is a line plot? You can tell me or someone beside you. Ready, go. and stop. If you said something like a line plot is showing measurement data, give yourself a thumbs up. If you said a line plot is like a number line, that is also correct. Or if you said a line plot shows data using x's, that is also an excellent answer. Here is an example of a line plot. What is the title of this line plot? The title is Number of Students in Each Grade at the School Baseball Game. So this is a little different than the line plots we've been practicing because this is not showing measurement data like centimeters or inches. It's just counting the number of students. So this is another way that we could represent data like number of students. A line plot is a graph that displays data using a number line, and it shows data using x's. So it's easy to read because we can quickly see which one has the most or the most common number. So here, which grade had the most students that attended the baseball game? If you said 4th grade, you are correct. It had the most x's or most number of students that attended the baseball game. I would like to review college-bound work from Friday's homework. So this was in your old packet from week of April 27th on page 71. Some work that I received, you were doing a great job including the labels on your number line or line plot, but we did have some mistakes and confusion about the questions. Make sure that you neatly wrote down your x's and recorded the numbers on the number line like this example. On the first question, how many towers were measured? A lot of you said 4 because you were counting this number right here. You said 1, 2, 3, 4. There were 4 towers measured. That is incorrect. You needed to count the number of towers on this side, so the number of x's. So you could count up all the x's, and the correct answer was 18 towers. If you got that one correct, give yourself a star or a check mark. On the next question, most of you were on track with this one. What tower height occurred most often? So which was had the most x's? And that answer was 15 inches. That was the one that happened the most often. Give yourself a star or check mark if you got that one correct. Make sure that you are drawing x's when you record the data on your line plot. Okay, we should not be using circles or any other symbols, please. Make sure that they are x's. Concept development time, we are going to complete page 10 together. I'll read, follow along. The students in Mrs. Washington's class each chose an item from her pencil box and measured its length. The table shows their results. So looking at the data table right here, what do we need to draw first on our line plot? The first thing we need to draw or label could be our title. See that we have this blank space right here, our title. And the title comes from what the data table is talking about. What do you think our title should be? You can tell me. Yeah, our title could be length of items in our pencil boxes, or length of items in Mrs. Washington's pencil box. Write down your title. What do you think we should do next? Next, we need to label our number line. what number goes at the beginning of our number line? Our first number should be 0, but our data and measurements here on the data table do not start at 0. What's the smallest length measurement in our data set? The smallest length measurement is 6 centimeters, so that will go next on the number line. What's the greatest measurement in our data set? The greatest measurement is 17 centimeters. So we need to label all of our hash marks counting from 6 up to 17. If your number line is not long enough, you can just keep drawing that line and extend the length. Make it as long as you need it. Your measurements should look like this. To save space, I did not include the numbers right here between 13 and 16. However, you could fill in the numbers in between, so going from 13, 14, 15, then 16 and 17. But I was just crammed for space. Make sure your title and number line is labeled and looks like mine. What do we need to do next? Next, we need to label what those numbers stand for, so the unit. So 6 what? Centimeters. We need to write centimeters at the bottom. And we have one final step. What should we do last? Lastly, we need to plot the data. So we need to draw the x's. Where should we start first? At the 6 centimeter mark. How many x's will 6 get? Hold up your fingers. Ready? 1. It needs 1 x. How many for 7 centimeters? 2. And the next one? 4. And the next? 5. And so on. So we will draw the x's above each number on the line plot. You should be all done creating your line plot for this question on page 10. Page 10, and then you can move on to page 11 for the questions. Question 1. What observations can you make about the data? Your answers might be different for this, so please share with me or someone beside you what observation you have made about this data. Ready, go. And stop. Here are some observations I made. I said most objects were 10 centimeters long and no objects were 12, 14, or 15 centimeters long. Please write down your thinking. Question 2. You can pause when you are ready to move on and press play when you're ready to join. What measurement occurred most often? The measurement that occurred the most often was 10 centimeters. That had the most x's. Record that answer. Question 3, still on page 11. What is the difference between the smallest measurement and the greatest measurement? Can you find the smallest measurement on the number line? So not the one with the least number of x's, the smallest measurement length. And then point to the greatest measurement length. Were you pointing to these numbers? If so, good job. We need to find the difference between 17 and 6 centimeters. What number or sentence should we write? Yeah, we could write 17 minus 6. 17 minus 6 equals what? 17 minus 6 equals 11 centimeters. The difference is 11 centimeters. Last question for our concept development. Do you think the data would look different if the students each chose a different item in their pencil box to measure? Why? So remember, they are measuring objects from their teacher's pencil box. You can tell me your thinking, yes or no, and why. And stop. Now, there could have been two different answers for this, so this is up for debate. I was thinking yes or no. I first was thinking no because the students measured all the objects from her pencil box and the objects will still be the same length. But then I was thinking some more, and it could even be yes, because there might be other objects left to measure and choose from. So if they're going to pick different objects to measure, those objects could be different lengths or new measurements that are not recorded yet. So this one was up for debate. It could be no or yes, depending on your thinking. That is it for our concept development. You are ready for your problem set, so this is your independent practice. Please turn to page 12 and I will read through each question. Mr. Enriquez's class measured the temperature each day during the month of May. Use the data in the table below to answer the following questions. Which temperature occurred most often? Point to your data table. Which column do you think you're going to be looking at to solve this question? You should be looking at this column right here for which temperature occurred most often. And then you should be answering one of the numbers like 59 degrees or 60 degrees. So which one had the most that occurred? I will do this one with you. The one that occurred the most often was 65 degrees. 65 degrees had 7 days in the month of May. So it occurred 7 times. So we are going to write down 65 degrees for the temperature that occurred most often. That little circle there stands for degrees. Number 2, which temperature occurred least often? Question 3, what is the difference between the highest temperature and the lowest temperature? So you're going to be looking at these numbers right here. Difference between 72 and 59. Number 4, how many days were recorded in all? So that means you're going to be counting up all those numbers of days. Last question, number 5, create a line plot below using the temperatures in May data table. So just like we practiced for our concept development, line plot needs to have a title. It needs to have a scale. So that's the numbers that you record along the number line. So you're going to be recording those numbers that had degrees on them. So the first number is going to be 59. Next, you need to write the units. So think about what unit is being used on this data table. It's not going to be inches or centimeters. The name of the unit for this is what? It is degrees. So you're going to write degrees at the bottom of this number line. Lastly, you're ready to plot the data using X's. Please have an adult check over your work when you are finished to make sure that you are on track. Last part of our video today, it is time for your homework on page 13. I need you to please turn this in to me when you are all done, so please take a picture of it and you can text or email it to me for credit. Use the data in the table provided to create a line plot and answer the questions. Plot only the lengths of shoelaces given. Number 1, the table below describes the lengths of students' shoelaces in Miss Henry's class. Remember the important parts of your line plot. First, you need to have a title. Next, you need to have a scale. After the scale, you need to write the units. So here the units are inches. And lastly, you need to plot the data using what symbol? X's. We don't use any other symbol on the line plot, just X's. Answering the questions, how many shoelaces were measured in all? Number of shoelaces can be found over here. Which shoelace length occurred most often? You need to use one of the numbers from here. Which one occurred most often? And then, which shoelace length occurred least often? Please text a picture of page 13 to me when you are finished and you will get a Grower Team Point. Remember, tomorrow is your test on Edulastic, so you do not have any pages to complete in your packet, just the online assignment.